This is a starter motor designed for big Chevrolet cars and trucks. I bought this originally because I am currently restoring a 1991 Chevy G20 van 5.7 liter, and I bought this mistakenly. Evidently, this particular starter does not fit in the 5.7 liter engine size, so I had to buy another one that was the correct size. This is extra. Conceptually, the starter is responsible for, as the name might suggest, starting the car. How does it do that? Last year, I made a video about how electricity and motors work, and I explained thusly wise. A motor is composed primarily of a kind of electromagnet. An electromagnet is a coil of wire in which is induced an electric current. The current flows through the coil as a result of voltage that is imparted to the circuit from a battery. The battery pushes electrons through the wire. As electrons move, the region of space in between the coils experiences an alteration in magnetic field. The world we live in is governed primarily by electromagnetic and gravitational fields that alter and change the properties of the regions of space in which they act. This is not something we fully understand as a civilization. It is just so that is what we observe. As electrons move through the wire, the magnetic field that movement induces in the region of space within the coil produces a force on magnetic objects that happen to be in that region of space. And so one way that engineers are able to make stuff happen in their devices is by using an electromagnetic solenoid, which is this part. A solenoid is a specific kind of electromagnet that can be turned on and off. When no current is moving through the wire, no magnetic force can be induced by the solenoid in its particular region of space. So we hook up this copper input right here to the car's battery so that we can induce a magnetic field in the solenoid that lives in this little cylinder. The current from the car battery flows through here, through the coil of wire, and induces a magnetic field in the solenoid, which produces a force. The force pulls a steel rod out. Attached to that steel rod is a gear. The gear on this particular rod moves slightly to the right so that the gear is free to rotate out here. Meanwhile, simultaneously, the same current is flowing through the actual motor itself. This is the main motor. This is the solenoid. The solenoid engages the geared shaft and moves it an inch or so to the right, so it pops out here. The actual motor is comprised of two main pieces that we care about, the stator and the rotator. Each one is a cylinder. The stator remains stationary. As current flows through the motor, it is flowing through the stator. The current flowing through the stator induces a magnetic field in the region of space inside itself. In that space, we add another component, the rotator. The rotator is designed so that when it experiences a certain kind of magnetic field, it will begin to rotate. It does this because of the interaction between magnets with opposing polarities. If one magnetic field is oriented clockwise in the stator, then engineers design the rotator so that when it experiences a clockwise oriented magnetic field, it rotates, and it does so very quickly depending on how efficiently the motor is designed. The main motor is attached to the geared shaft that we talked about a second ago. The gear that comes out right here interfaces in the car with a very big gear that is attached to the engine. If we could provide enough force, enough torque to turn that large gear, we could start the engine by hand. As a matter of fact, automobiles from the early 20th centuries, you had to start it by hand but now we have the electric starting motor. The small gear in here spins very rapidly, and that turns the large engine gear also relatively rapidly. And this turns over the engine, which is what inevitably starts the internal combustion cycle in a modern car engine. That is how the starter motor in your car works. Thank you.